All right, good morning, good afternoon, good evening, wherever you are. I hope you're doing great. Welcome back to geometry class here, and going to fill you in on some information on some of those shortcuts that I've been trying to tell you guys that were coming as far as proving triangles congruent. Now again, just want to review a couple of things. Why are we working on proving triangles congruent? Well, they're the most basic, strongest structure that we can work with geometrically. And if you look at any form of engineering or industry, a lot of things revolve around triangles. And you're going to see that. I've had students in the past tell me, you know what, Mr. Couples, everything comes back to triangles in geometry. And that's really pretty much the truth, okay? And so from now until about the end of the third quarter, we're going to be studying different types of triangles and how to manipulate them to work what we want to do. So before we get going here, I want you to pull out your vocabulary packet. If we haven't already filled in these things, I want to make sure you get them filled in, and then we'll move on from there. So the first term is congruent polygons. Now if you remember in our last lesson, congruent polygons have two distinct characteristics, and they have to have these, otherwise they won't be congruent. The first thing, if you remember, is congruent corresponding sides. So you can go ahead and jot that down there. Congruent corresponding sides is one, and the other would be congruent corresponding angles. And so if I get going too fast here, of course you can pause or stop the video and go back and listen to it again. But again, congruent corresponding sides and angles are the characteristics of all congruent polygons. If you look there on the page, it says congruency statement. It doesn't have to be a triangle. It can be any type of shape. But I put triangles there because that's what we're going to kind of focus on in this chapter. And so it's triangle what is congruent to triangle what, okay? Now remember, you have to match up those corresponding angles to each other, okay? And after you've done that, you don't need the picture anymore. You know exactly what parts are going to be matched up with each other from that point on, okay? All right, now theorem 4.1 we talked about yesterday, and again you can write this shorthand as I kind of stress to you guys, but if you just want to fill it out, theorem 4.1 says this: if two angles from two triangles are congruent, then the third angles are congruent, okay? And again, we won't use that theorem a lot in geometry, but it's kind of in your toolbox if you need it. You can pull it out every now and then. So don't forget about that theorem. If two angles from two triangles are congruent, then the third angles are going to be congruent. All right, now the next thing I want to do is I want to show you a quick video of, oh, did I not pull it up? Okay, I'm going to pause this for a quick. All right, so I thought I had everything pulled up on my browser, but I guess I didn't. So here's what we have. Basically here, I'll just read the statement to you. Now, and again, this is the first video I ever made, so it was kind of rough. Bear with me as I show it to you. But congruent polygons have congruent corresponding parts. Okay, we know that, sides and angles. However, it is not necessary to prove all the corresponding parts of the two triangles congruent. I've told you that. As you'll see in postulates 4.1 and 4.2, there are shortcuts to prove the triangles congruent. So here's what we have. I'm trying to show you right now one of those shortcuts. And so what I'm doing here is comparing the length of AB to the length of EF. And as you can see, those two lengths are the same to each other, okay? I'm going to take a look at the length of AC, and I'll compare that to the length of ED. Oh, and they're the same length as well, okay? And then I'm going to take a look at the last side that we have here. So the length of BC, is it the same length as FD? Well, if I go over there, we can see that it is, okay? And so as a result, what's the shortcut? Well, the three sides of the one triangle, well, they're going to be congruent to the three sides of another triangle. Are the figures congruent to each other? Well, I rotated it there, and now I'm going to click on it and slide it just to see if the two figures are going to be congruent to each other. Okay, and here's what I want you to see. And not only are all the corresponding sides the same length, but all the corresponding angles are the same measure. And so, yes, we know we have congruent polygons, and I'd like you to write that right there down in your vocabulary sheet. If we'll, let me go back real quick. Okay, if we look at your vocabulary sheet here, pull that up, okay, we've got postulate 4-1, side, 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 okay. Now, whenever you want to use side, 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 all you have to do is put down SSS, okay. That's a quick and easy way to tell me what you're trying to say. You don't have to write out this entire postulate, but what I want you to do is to write down the entire postulate here so that we know that you know exactly what we're looking at. So again, here's what the postulate says. You might want to pause your computer for a quick second here and get that written down for me. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the 2 triangles are congruent. Okay, so again, that's the side, side, side postulate, or postulate 4-1. There is one other postulate we want to look at today, which is postulate 4-2. And in this postulate, what I'm looking at here is the measure of angle A. And if you look at angle A, it's slightly more than 100 degrees. It's like maybe 100.5 degrees. And angle F, well, that's the exact same measure. Okay, so I mark those 2 angles congruent to each other. Okay. Now I'm going to compare the side length of AB to the length of, I believe it's going to be, oh, it's FD. Okay. Those 2 are the same length. AB and FD are the same length. And the length of AC, I'm going to compare that to EF. And what we see there is that those 2 are going to be the same length. Okay. So what we have right now is our 2 congruent sides and the included angle. Now that's the key part of this whole theorem, the included, the angle that's between those 2. Okay. Here's where it gets a little rough as I try to show that these 2 figures will eventually be congruent. I don't know if I had a, I don't know, just didn't rotate it very well, so I kind of fight with it here a little bit. Go back and forth. I'm going to speed this up so you can see everything. And I think you can see it now. They're going to be congruent. You know, I don't have to measure all those other angles, the other 2 angles, or I don't have to measure that 3rd side. Whenever you have side angle side, you have a pair of congruent triangles. Okay? And that's all you need. So side angle side. So moving on from there, okay, you want to put this down with postulate 4-2. Okay, I think postulate 4-2, if I can pull that up here, 4-2 is right there. And just like this one where we put down side, 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 or SSS, this one's going to be side angle side. So if you put SAS, I know exactly what you're talking about, the acronym there. Okay? All right, now there's, well, go ahead and jot that down for me. If 2 sides and the included angle, and if I were you, if you're a highlighting person or if you like to box things in, the key term is included angle. Of one triangle are congruent to 2 sides and the included angle, again, the key term, it's got to be between the 2 congruent sides. That's what included means, between 2 other things. So included angle of another triangle, then the triangles are congruent. Okay. Now the last thing that I want to show you guys is this, and that's actually a typo right there. It's supposed to say, is it possible to conclude the 2 triangles are congruent by side, side, side? Okay, I said that wrong, by angle, side, side. So what I'm going to do here is I'm going to draw out a side length that is the same. Okay, those are both 7 units long. And then I drew out another segment. It doesn't matter what length that was, I don't believe, so I just drew out another segment. And what I did was I slid that ruler down, so those lines are parallel, so I know that those angles are going to be congruent to each other. Okay. Now I'm just throwing in a 3rd side of that triangle. Doesn't matter where I throw that 3rd side in. Okay. And what I'm going to do is I'm going to measure that 3rd side length and then transfer that over to the other triangle. Okay. So as I transfer that, here's what I want you to see. This 3rd side could go in right here, okay? And if I throw that 3rd side in right there, then I would have angle side, side, and the triangles will be congruent. However, right here I have angle side side because these three match up with these three. This angle here matches with this one. Okay, so this angle matches with this one. This side matches with this side. And this side matches with this side. Well, obviously these two triangles are not congruent. And so as a result, we cannot use angle side side because it won't happen in all situations. There are some where it's not possible. Now, if you can't remember that, I want you to remember the acronyms of the ones that do work. You have SSS, or side, side, side. You have side, angle, side, SAS. And remember, I do not want to see this on anybody's test, a justification using angle, side, side. Now, think about it for a second, people. All right, so hopefully some of you kind of got a little smirk to your face here, okay? I don't want to see trying to prove triangles congruent by ASS, okay? It is not possible. The unfortunate thing is there will be many of you that will get in the zone when you do your quiz and you will write that down, okay? And I will circle it and say, really? Come on, people. So, again, angle side side, not a possible way to prove those triangles congruent. All right, now, moving on from there, here's what I want to do next. I don't think there's anything else I wanted to show from there. Yeah. Okay, so looking at, you've filled in those two things, and if you want to, you know, just to make sure that you've got this down, you can go to the very top of your paper here and write down ASS, angle side side, and put a big old line through it, okay? Maybe some stars around it to bring it to your attention because I don't want you to make that mistake on a test or quiz. All right, now, if you pull out the worksheet that I gave you for your notes here, I want to talk you through what you need to be thinking about when you look at different types of problems considering what we've talked about already. So the first thing is this: what other information would need to be determined in order for the triangles to be congruent by the following, okay? So if I was to go ahead and prove these triangles congruent by side angle side, what else would have to be determined? Well, in number one, we already know that we can use the reflexive property because segment SK is going to be in both of those triangles there. And so, let me pull something down here real quick, get my pen tool. Okay. So what I'm going to do is I'm going to mark those two that segment congruent to itself, and I'm going to move on. That's obvious. We know that's already true. I don't need to, what does it say up there? What other information would need to be determined? I don't need to determine that, okay? It's already there for me. It's already been determined, okay? So the question would be, if I've got a side and I've got another side, which angle would I have to prove congruent? Now remember, the key term when we talked about side angle side was the included angle. So which angles would be included between those two congruent sides? Well, if I look at this angle here is not between the two congruent sides, okay? This angle here is not between the two congruent sides. If I go to this angle here is between those two congruent sides. Over here, the two sides that make up the angle aren't congruent. These two sides that make up this angle aren't congruent. But these two sides here are congruent. This is the angle I would have to prove congruent. So off to the side, I could go ahead and make a little note of this. I'd have to prove angle RSK would have to be congruent to angle TKS. Okay? And so, yeah, that the included angle, the key thing there. For the next one, side, 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 this one's a little bit easier. Obviously, AC is congruent to itself by the reflexive property. I know that AB and DC are congruent because they're both the same length. So what else would I have to determine in order to use side, side, side? I would have to determine that AD is congruent to BC, okay? And since we don't know the length of BC, that's why I would have to determine it. So again, I'd have to determine this in order to use side, 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 okay? So yeah, hopefully you're getting a better understanding of what side, side, side is and side angle side will be, okay? Now, looking at, can I move that like that? Nope, can't do that. Looking at the next section, here's what it says. From the given information, can you prove the following triangles congruent? Okay, triangle RED and triangle CAT. All right. Now, one thing I know right off the bat is that as I look at the congruency statement, I know that angle R has to correspond with angle C. As I look up here, angle R corresponds with angle T because of the congruency markings there. So that's the first thing that tells me that's not going to be possible there. The second thing is this: they have to be marked in a corresponding manner. And so if I go from 2 to 1 to 1, meaning two congruency marks, one congruency marks with an angle, one congruency mark with a side, then I have to go from 2 to 1 to 1. So this would not be possible because corresponding angles are not congruent. Corresponding angles are, I'll just use a congruent sign with a slash through it, are not congruent, okay? They have to match up in a corresponding manner, okay? Well, let's look at the next one. AEB and DBC, okay? Well, the first thing that kind of comes to my mind is that, well, as I look at the picture, I know I have vertical angles congruent, so I'm going to mark those two congruent to each other, okay? And that would mean that angle DBC would correspond with angle ABE. Well, that doesn't match up. This angle here and this angle here aren't matched up in the same position within the congruency statement. That's one reason why I can tell these triangles aren't going to be congruent. The second reason, I would go ahead and look at the fact that I do have side angle side over here. And over here, what do I have? I have angle side side. They're not matched up in a corresponding manner. And so, you know, again, you could probably go ahead and say this, or even, I could go even one step further. If these two sides are the congruent sides, the corresponding sides would have to be these two here, okay, AB and BE. So as a result, you could actually use both characteristics of congruent polygons, the fact that we don't have congruent corresponding sides and we don't have congruent corresponding angles, okay? So enough of that. If that was a little confusing to you, and disregard that part, the really important part is from here on down, okay? And so as I look at this next section here, this is what I really need to make sure you guys understand moving forward. And here's what it is. Determine whether you can use side, side, side or side angle side postulate to prove the triangle's congruent. If so, write the congruency statement and identify the postulate, okay? So as I look at number 5, the very first thing that should come to your mind as well as mine is I have a side length that's shared. Whenever you have a side length that's shared, you want to mark that congruent right off the bat because of the reflexive property. Now I look at my picture and I say, okay, do I have side, side, side? No, I don't. I don't know that AD is congruent to DC. Do I have side angle side? I do. And the reason is because this angle here at B is between the two congruent sides, as is this one, okay? So what I'm going to do after I do that is I'm going to write down the congruency statement. Now the congruency statement will be something like this. It doesn't have to be exactly like it. You can change it. But I'll go ahead and say this. ABD triangle is congruent to triangle CBD, okay? If you start with a different letter, for example, you could also say triangle DAB, DAB, is congruent to triangle DCB, okay? And so there's lots of different combinations you can put up there. Just make sure you're matching them up correspondingly. And then I would like you to put down underneath that the reason for which we know the triangles are congruent, side angle side, okay? For number 6, we've got two pairs of congruent sides, but the triangles are separate from each other. And I'd like you to make a special note of this on your paper there, and I'll be looking for this when I check your notes. In number 6, I would like you to write down something like this. 1, there's just not enough information, okay? But I'd like you to put a star next to this next part, and that's this. When triangles are separate, nothing else can be concluded, okay? Outside of the given, there's nothing else we can conclude if they're completely separate of each other, like number 6 there. Okay? So I'm going to put down here not enough information, and when triangles are separate, no other information can be determined. Okay? In number 7, what do we have present there? Do we have side, side, side? No. And again, they're separate from each other, so there's nothing else I can prove that isn't already stated within the problem. Okay? Do we have side, angle, side? And the answer is no. The angles that are proven congruent here that are given to us are not between the two congruent sides. Okay? So what do we have? Well, we have angle, side, side. Can we prove triangles congruent by angle, side, side? No. Okay? So what I would put down on my paper there for number 7 is something like this. Triangles cannot be proven congruent by angle, side, side, or ASS, whatever. I don't care what you put down, but make sure you're reinforcing that understanding that angle, side, side is not an appropriate response for proving triangles congruent. Okay? Now, let's actually work through the next 2, and then I would encourage you from 10 to 13 to pause your computer and see if you can figure it out. I think you could do those probably even faster than I can state them. So as we look at number 8, triangles are completely separate again. And so we want to ask ourselves, do we have enough information to prove the triangle is congruent? Do we have side, angle, side? No, we don't have any of the angles proven congruent. Do we have side, side, side? Yes, we do. Okay? And so with side, 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 I'm going to put that down, side, side, side. I'm going to put down triangle. Now, you want to choose a vertex. If I go ahead and do STU is congruent to triangle. Now, notice the S, this vertex right here, lies between a side marked with 2 congruency marks and a side marked with 3 congruency marks. The vertex on this triangle that is the same thing would be V. Okay, 2 congruency marks there and 3 there. So I'm going to start with V. Now T is between 2 and 1. So I go over here. Here's 2, here's 1. The one that's between that is X. Okay, and then W would be the last one. Okay. So again, if I were to start differently and choose a different point, I could go, let's say UTS. All right. If I do triangle UTS, the corresponding triangle would be triangle WXV. Okay. And notice here, folks, all I did there, I can look up here and do that, but if you start with U and go TS, start with W and go XV. Okay. And so it just has to go in the corresponding order. For number 9, do we have enough information to prove the triangle is congruent? Well, if you look back at number 5, those triangles are matched up side by side. First thing I'm going to do is I'm going to mark this right here. Okay? Now, the unfortunate part about this one here is this. YA and AB, or ZA and AB, they look congruent to each other. But there is no way I can prove them to be congruent. There's nothing we've learned this year that would help me with that. I also know that YZ and YB look congruent to each other. Again, there's nothing we've learned this year that would help us with that. I do know, and I probably should have stated this at the beginning, with this angle being a right angle, that this angle is also a right angle. Okay? So that is helpful. But the unfortunate part is, with only one pair of angles congruent, I don't know if these two are congruent, and I don't know if these two are congruent to each other. So as a result, I'm going to put down for number 9, not enough information, and that's really all you have to put. Okay, we've got a side, a pair of sides, and a pair of angles, and that's it. Okay. All right, like I said, if I were you, I would pause my computer from here on out, do numbers 10, 11, 12, and 13 on your own, see if you can figure those out, and then press play again. Okay. I'm going to continue on here, and you can double check your answers when you're done. All right, so number 10, triangles are separate. There is nothing we can prove outside of what's already marked down as the given. So what are we going to do? Well, let's ask ourselves, do we have side, side, side? The answer is no. The hypotenuses from both those triangles are not congruent. Do we have side, angle, side? Oh, yes we do. The angle between the two congruent sides are congruent. So I'm going to put down here side, angle, side, okay? And then you want to match up your triangles. Now, if you went ahead and said something different than what I did, then see if you can match up the corresponding order. So for example, if I go ahead and do CDE, okay, I like to put them in alphabetical order there, CDE. If I go to the other triangle, the vertex or angle that corresponds with C would be F. Okay, you see that once in congruency mark? Okay, so that would be F, and then we move to the right angle, G, and then H. Okay? Now, well, again, if you didn't have that same thing down, let's say you had D, E, and then C. Well, if I go over here, you would have to match up G, H, and then F. Okay? Just match up the corresponding order, and you can double check yourself to make sure you've done those correctly there. All right, 11, 12, and 13. If we take a look at those three, clear that off. Number 11, ooh, too far. Try again. Go up, nope. There we go. Making little noises to myself. All right, number 11 is, it's adjoined. There's a side that's shared, and so as a result, I can use my reflexive property and mark that down. All right. Now, do we have side, side, side? No, we don't. Okay. Do we have side, angle, side? Well, we have an angle between the two congruent sides there. We have an angle between the two congruent sides there, so I do have side, angle, side. Okay. Now, again, matching up those two triangles. Okay. Let's go ahead and do KLM. All right. And then if I do the other triangle, now here's what I need you to look at. This can be a little confusing here. This angle at K right there has the two congruency marks here to none. So when I go over to this triangle over here, the angle that goes from two congruency marks to none would be here, here, so it would be M. These two angles correspond to each other. So it's going to be M. If I go KL, it'd be MJ, K. Okay. Now I know some of you are picking up the congruency statement real quick and easy. I just want to make sure if those that are struggling, they're getting it. That's the key there. All right, number 12. Look, I've got joining parts to my triangle. So I'm going to use the reflexive property again. And that's beautiful because now I have a pair of congruent triangles. By what reason? Hope you're all saying side, side, side. Very good. So if I put that down, okay, going to put my congruency statement down. If I do PQR, that would be congruent to triangle PNR. Okay, and again, if you have any combination, make sure they're matched up correspondingly. Okay. Number 13, I know I stressed this in our last class, but I want to make sure that you continue to hear this. Whenever you have a pair of vertical angles, mark those guys congruent before you do anything else. Okay. Now, from there, is there enough information to prove the triangle's congruent? Well, I can't prove anything else within those two triangles congruent right now. Okay. And all we have right now is angle, side, side. And so if I were you, I would just go ahead and put down not enough information, okay? And I'm going to say cannot prove triangles congruent by angle, side, side. Now, what if we were to change one thing? I'm going to change up one last thing here before we finish up. What if we were to go ahead and say this line here is parallel to this line here? How does that change things there? Okay. Well, that changes things as far as our polygons are concerned in the fact that since I have parallel lines, I also have congruent angles. Now, which angles do I have to have that are congruent? Well, it's either corresponding or alternate tier. I'm hoping that you're thinking alternate tier. Now, some of you may have already marked down that this angle here, it would be congruent to this angle here, which is true, but so would this angle here and this angle here. Okay? Now, if those lines were parallel, then would the triangles be congruent? And the answer is yes. You would have side angle side, let me point it out, side angle side here, and you would have side angle side there, okay? So I'm going to go ahead and just jot that down real quick. The way it was marked out originally, no, it was not possible to prove the triangle's congruent. But if I use side angle side with the parallel lines here, that does make it possible. So I can go and say STU is congruent to STU WVU. All right. I very much appreciate your attentiveness there, guys. I hope that was understandable. You have some practice problems online I'd like you to work on. When you get done with that, make sure you show them to me, and I'll give you credit for it. So, again, thanks for listening. Have a great night.